Hello, and welcome to the pre-lab video for our final lab together for this semester. Today we are going to be looking at moderation, and we will be going back to our lovely vampire data set in order to play around with moderation. So, looking at our model, our hypothesis is we think that population density will moderate or change the relationship between attractiveness and number of souls harvested. So in other words, we're wondering if the relationship between attractiveness and number of souls harvested depends on population density. Now, before we get too far into this data, let's first go over the basic assumptions. So, here's our data set. This is looking at it from the variable view. We have these 10 variables, which are described here. And essentially, we are just looking at attractiveness, population density, and souls harvested. Those are the three variables we want to look at today. Now, it's important to remember that just because what we're doing isn't a typical regression doesn't mean that we don't need to still check our assumptions. So here, even though we're going to be doing this through the process macro, the assumptions for a regression still stand, because at the end of the day, it's a regression that we're doing, just a fancier version. And so because of that, we want to double check that this meets all of those criteria for, have we met those assumptions? Now with 500 cases, I'd say that we're pretty confident that we have the sample size down. But why don't you pause the video here and go through the data and check all of those assumptions before you come back. So pause now. Okay, so did you check? What did you find? How does it look? So I just ran a regression. Soul harvest is the outcome with these two as the predictors, and just did the normal things. So this is the syntax that I used to get this. Now, again, I'm not looking too much at a lot of these things, but overall things look pretty good. And I just told it to give me case-wise diagnostics, so it flagged for me anything with a standardized residual above 3. I had 2 cases, and because I'm being lazy and I have 500 cases, I just deleted them. But otherwise, other than these 2 cases that you can see here, very obvious outliers, the rest of it looks pretty good. Now this doesn't look beautiful, but I'm sure if I ran this again with those outliers removed, it would look a bit better. So always make sure to check your outliers for your assumptions. Now we get to the fun stuff. So going back to our moderation model, remember that moderation differs from mediation because instead of the relationship between x and y being caused by the relationship between X and W and Y. Instead, it's just that the levels of W impacts what that relationship is. So how we test this in SPSS. So first, we already have the data set open, and I've already loaded in the process macro. So if you haven't done that, do that now. Now, next is to specify the model. So we have what it should look like here. And again, I'll ask you to just pause and put this, write the syntax out for yourself. So pause now, and when you come back, let's see how you did. Okay, so how does it seem? Did you get something like this? Oh, it's so small. It's a bit better. So here, all I changed, so here we just had to say our Y is soul harvest, X is attractiveness, and W is pop dens. Again, that's just, all right, that's just what we put for this original model. Okay, so hopefully you got this. Now the model that we have written here is 1. That's because in the process, 1 is a moderation model. Additionally, we need to have centered variables for moderation. So that's just essentially means let's take everything and not necessarily standardize it, but do half of the equation. We want to make 0 be the mean. And that's because if 0 isn't the mean, things stop making sense, really, with moderation and get messed up. So here, we haven't pre-centered the data. We haven't already gone through and subtracted the mean from pop dens. And so we are including the center equals 1 line in the code, just so that the program will center the data for you. This JN equals 1 gives you a Johnson-Newman analysis, and we'll go over what that is. And it just helps to show us what we get. So I'm going to just run this regression, and let's see what it looks like. Okay. So now we have this. Again, you can double check that you've done the model right by looking up here. It says model 1. I already said that model 1 is a moderation. Y is soul harvest, X is attract, and W is population density. You can also tell that it's the correct model because you probably noticed that last week when we did mediation, that was M, not W. So W refers to a moderator, M refers to a mediator. I think we just do it just to be silly, but it does help somewhat to curb confusion. Now your results might be slightly different depending on what your data cleaning looked like. Do not worry, it'll be similar enough. Okay, so here we have the overall model summary with soul harvest being the outcome variable and attract and population density being in there. But more important is this interaction term. Essentially, what moderation is doing is seeing, is there an interaction between attraction and population density in how they affect soul harvest? And from this interaction term, we can see yes, there is. This is significant. And so that's really all we want to look at from this top part. Is the interaction term significant? And that's also what this next part gives us, the tests of highest order unconditional interactions. Above, this was giving us a t-test. Here it's giving us an f-test. So remember, they're essentially the same. Don't worry about it. The r-squared change is how much additional variance are we able to explain when we consider the interaction between these two variables instead of just each variable on its own. And that's a significant amount of variance. Now, the fun part of the moderator is interpreting what is it? What is our difference here? And that's what all of these tables are for. So first we have this conditional effect of the focal predictor at values of the moderator. So that's saying, what is the effect of attractiveness on population density at these levels of the moderator? So at 17, or rather 18 units below the mean, at the mean, and 18 units above the mean. Remember, we mean-centered this. So we can see 18 units below the mean, there's, for every 1 unit increase in attractiveness, there's a 3 unit increase in number of souls harvested. And that is significant effect. And then as we go increase to 0 approximately, so at the mean, it's now for every 1 unit increase in attractiveness, there's a 9 unit increase in how many souls are harvested. So 1 more unit of attractiveness gets you 9 more souls at the mean level of population density. And then at high levels of population density, 18 units above the mean, we see 15. The relationship increased to 15. So for every 1 unit increase in attractiveness, there's now a 15 unit increase in the number of souls harvested. So essentially this is showing us what is this change. So is there a change between these effects? Now that can be helpful because we can see, okay, qualitatively, the size of this is increasing, right? It looks like this is the higher the population density, the stronger the relationship is between attractiveness and souls harvested. However, that doesn't quantitatively tell us that there's a difference. And that can be one of the things that this Johnson-Newman significance test can do. And so looking at this test, it tells us, okay, at what point does this go from not being significant to being significant? So here, it's actually saying that for values below 19 units below the mean of population density, there's no relationship between attractiveness and number of souls harvested. But at values above negative 19, so if it's 19 units below the mean or greater, so negative 19 plus, then there is a relationship between these. It's not always going to be this just one value here. It's actually pretty common for there to be multiple. So if we think about how this could look, I'll probably draw a picture in lab or something of what some of these interactions could look like. It isn't just always going to go from not significant to significant. It could go from not significant to significant and then not significant again, or vice versa. Significant, not significant, significant. Or it could go from significant to not. The way it can work can change for sure. Don't worry about it too much. I'll draw a picture because I like pictures. But yeah, so this tells us, okay, below this value, it's not significant. Now, this table, and this is essentially as close as the process will come to giving you tables. They don't give you proper tables, but think of these as tables. For the conditional effects of focal predictor at values of moderator, this essentially gives you similar to this. I hate that it does that. You can't see my pointer, but this 3-line table in the middle of the screen, or at the top of the screen now, similar to this table, all it's doing is it's giving you the same info, but for way more points. And so this essentially allows you to see where does this become significant, and what does this relationship look like throughout the entire values. Now, one of the nicest things about the process macro for doing this is this. Data for visualizing the conditional effect of the focal predictor. And so all you have to do is copy paste this syntax. Let me just try and make it so that I can do that without it going everywhere. Yes. So I'm going to copy this, and I'm going to just directly paste that into here. I don't need to do anything else. It gives me the syntax needed. If you go over here in the data in the document, you can see it's telling you we just want to run what the lines are here. So I'm going to just run this. So once you run that, you can you get this graph. Now you can also double click on it and essentially get a there we go. So I think it's easier to see when it's lines, so I just changed here it from, you can barely see it, changed it from just markers to fit line. Doesn't matter really which one you do. So now, look at it a bit bigger. We can see there we go. So now we can see that below the mean, there's a very small relationship, and this is above the Johnson-Newman significant cutoff, significant region. So we know that this is a small but still non-zero effect. And we see that the slope of this line is increasing as the population density increases. So there's a stronger relationship between attractiveness and Souls Harvest at higher levels of population density. Okay, so going back to the lab document, we have just these two questions, and I've already pretty much gone over them, but I ask you to write it down. So write down your interpretation, like write down the results, and then write up your interpretation of the visual interaction. Finally, if you are a very brave soul, feel free to try doing this in SAS. We also provided the CSV data. Now you can just load that right into SPSS, but and you can load .sav data into SAS, but sometimes it's just nice to have .csv when you're working with SAS. It can make it a bit easier. So yeah, feel free to try doing this in SAS. Remember, next semester we're going to do everything in SAS. Yeah, that is it. I look forward to seeing you all on Monday for our final lab. See you then.